Okay, so let's have a look at a few solutions, shall we? So obviously we're talking about the area. What are we talking about? The volume of solid revolution. So key things here, it's about the x-axis, which means it's dx, pi y squared dx. So we have a difference of functions. So you can see clearly here the top function is the one in blue. The bottom function here is the one in green, which means our integral or our volume is pi, top function squared minus bottom function squared dx. Top function squared is a 4 over 2 plus 1 on x squared. So that's, I guess, one possible mistake, forgetting to square the 2 to give us 4, minus the bottom function squared, which is just y equal to 1. So C is our answer. 16, we don't have to worry about. We don't do the trapezoidal rule anymore. Again, we've got another area rotated about the y-axis this time. So y-axis, dy. So pi x squared dy. So first step, transpose to rearrange to get x as the subject. So sine inverse. So we can take the sine over, divide by 2, square everything. We get a quarter of sine squared y. Just having a quick look at their solutions or possible solutions. They've got it in terms of cos 2y, which means they've used the trig identity for sine squared y. So there it is there, 1 minus cos 2y. Just tidy that up a fraction, and we get our 1/8 of 1 minus cos 2y, which is in here. So there's pi on 8. So it's one of those three. There's our 1/8 out the front. Put our u values in. So I haven't really put that in clearly, have I? So what are we going to do? We're going to have at, what have we got? It's just in terms of y, so it doesn't matter. So we're not doing any substitutions. So our y values, 0 to pi on 2. The pi at the front with the 1/8 gives us a pi on 8, 1 minus cos 2y, and gives us c. Times any one of those particular areas. Let's go, jump to page, have we? Yeah. Okay, graph the function, antiderivative shown here, blah, blah, is closest to. Okay, so what we're really harnessing on here is the graph of the function we're interested in and its antiderivative. So it's the green function that we're interested in. So the green function is the one we're interested in. And so it's that green area there, the integral between -3 and 0, f of x dx. All right. So what's that equal to? Well, we anti-differentiate that function, and typically we write it as capital F of x, which is the antiderivative. Substitute your terminal points in, and so we get f of 0 minus f of -3. So if we go to the antiderivative function and work out f of 3, f of -3, and f of 0, and that gives us -2 minus 7, which is -9. We've got an area, so the first thing we do if we're looking for an area, is to sketch a graph. And so clearly we can see that the areas that we're interested in between -pi and 2 pi, I think it is, there's 3 of them and they're all the same. Yeah, so we could have picked, so times that area by 3 or that by 3 or that by 3. So we'll just tick the one typically, not that it'll matter because we're using a u substitution. So our sine cubed, sine x times sine squared x, sine squared is 1 minus cos squared. If u is equal to cos x, well then at x equal to 0, u is 1. At x equal to pi, u is -1. So the corresponding integral in terms of u is there. Don't forget that negative sign there from in here, because then du dx is the derivative of cos x, which is negative sine x. So negative du is equal to sine x dx, yeah? So we've got a few negatives everywhere. We've got one here. Oops, probably not the best way to do it. We've got a negative there. Now we're going to swap our terminal points around. Yeah, so it gives me another negative. So we've just got to be a little bit careful. So I guess if we take it a step at a time, we've got this function here. I'm going to swap the negative to u, so that negative comes out from here. I'm now going to swap the 1 and -1 to make it a positive there. And the positive -1 to 1 of 1 minus u squared is b. Last multi-choice. Again, we've got another volume here, rotating about the x-axis. So it's about the x-axis, so dx, so pi y squared dx, top function minus bottom function squared if we need to. So what have we got? The top function, I guess I could have color-coded, about the x-axis. So there's my top function there. Yeah, sine squared minus my bottom function, 1 minus cos x, which is there. So that sets it up. All right. Now in exact volume, so it's actually not a multiple choice, as I'm going to say. From there you can put it in your CAS and check. So we'll just have to work through it. Sine squared x, so we've got our double angle formula in here. 1 minus cos x all squared. 1 minus 2 cos x plus cos squared x. Negative out the front means I actually get a sine squared minus cos squared, which is the negative of cos 2x. Okay, because cos 2x is cos squared minus sine squared. So just that blue underlined section there, the sine squared minus cos squared, corresponds to that 1 minus, or the minus cos 2x. From there, anti-differentiate each term. So the integral of cos is positive sine. The antiderivative of cos 2x is 1 on 2 sine 2x. Sine doesn't change. Just be careful substituting things in. We put our pi on 2 in, we get a 1, and we get 0 for sine 2x, and we end up with pi on 2, 4 minus pi, which is an equivalent CAS expression there. All right, so I guess it's really just knowing your rule. This is quite a reasonable short answer question. Okay. Moving along. Question 5, another area, or volume is it? First, an area. Find the exact area of the shaded region. So as soon as we see it's an even function, yeah, it doesn't matter whether I put in positive x or negative x, I'm going to get the same function. And you can see it from the symmetry of the graph. So as soon as we get that, I think between 0 and 2 as opposed to -2 and 2. So that's what I've done there, 2 times the whole thing, split the integral up. So I get 1 dx, which is just the integral between 0 and 2 of x, evaluate that. And I've taken the 4 out, I guess it's identifying nice and early that 8 on x squared plus 4 is a over x squared plus a squared. So we're going to get 4 times tan inverse of x on 2. Evaluate between 2 and 0, substitute those points in. Again, tan inverse of 1, pi on 4, tan inverse of 0, 0. Yeah, and so if you just be careful with the way you evaluate that, we get our corresponding answers there with the CAS. Now we're going to rotate that region about the y-axis to form a solid of revolution. So it's about the y-axis, so it's pi dy, so pi x squared dy. First thing I did, rearrange to get x squared equal to. So there's my expression for x squared. So the volume then is between pi, the y values that I'm interested in are between -1 and 0, and that's x squared there. Okay, x squared is 8 over 1 minus y minus 4. So just be careful with evaluating that. Don't forget our antiderivative of 8 on 1 minus y is the natural log absolute value of 1 minus y. Just in case we get negative signs in there, we need to know we can still evaluate them. Okay, so substitute key points in, and we get pi outside of 8, natural log of 2 minus 4. Look, I guess back in 2003, we'd certainly be expecting to work with that sort of question as an exact solution. All right.